nuclear physics. Liquid drop model. The precise nature of the forces acting in the nucleons are yet unknown. Scientists came up with various models considering the similarities between the nucleus and liquid drop, considering the similarities between nucleus and the shell model. In our class, today's class, we will be discussing about liquid drop model. Liquid drop model in nuclear physics assumes that the nucleus is a drop of incompressible nuclear fluid. It was first proposed by George Gamow and then developed by Niels Bohr and John. The essential assumptions of the liquid drop model are that a spherical nucleus consists of incompressible matter such that R is proportional to cube root of atomic number. The nuclear force is identical for every nucleon, and the nuclear forces are saturated forces. And in this figure we can see the similarity in the arrangement of neutrons and protons to that of the H2O molecules or in a water drop. If we consider the liquid to be water, the way the H2O molecules are arranged within a liquid drop is similar to that of the way neutrons and protons are arranged. And then the analogous between a liquid drop and nucleus can be said as follows. Both are spherical in nature. In both cases, the density is independent of its volume. The molecules in a liquid drop interact over short ranges and is true for nucleons also. The surface tension forces act on the surface of a liquid drop while a potential barrier acts on the surface of a nucleus. When the temperature of the molecule in a liquid drop increases, evaporation of molecule takes place. Similarly, when the nucleons in the nuclei are subjected to external energy, a compound nucleus is formed, and this is known as nuclear fission. That is, the nucleus is supposed to have a spherical shape in its stable state similar to that of a liquid drop. A force due to surface tension acts on the surface of the liquid drop, and this force is similar to that of a potential barrier on the surface of the nucleus. The density of the liquid is independent. Similarly, the density of the nucleus also independent, as we have earlier discussed in properties of nucleus. And molecules or atoms in the liquid are attracted by short range forces. Similarly, nucleons in the nucleus are attracted by short range nuclear forces. Liquids exhibit the phenomena of evaporation, which can be compared with radioactive property of the nucleus. Upon oscillation, the liquid drop breaks into components. Similarly, the nuclides will also undergo the process of nuclear fission. The energy necessary to evaporate drop is proportional to mass number. Similarly, the binding energy of the nucleus is proportional to A. So, these are the similarities between the liquid and the nucleus, liquid drop model and the nucleus, as it has been proposed in liquid drop model. The concept is also used to find the mass of the nucleus, and the formula given in this model is called as semi-empirical formula. This semi-empirical formula says that the binding energy is a sum of volume energy, surface energy, Coulombic energy, asymmetric energy, and pairing energy. That is, the total force of binding energy of the nucleus is contributed by all these 5 components, among which some are associated in increasing the binding energy, while some of them are associated in decreasing the binding energy. That is, some forces are positive whereas some forces are negative. Volume energy. When we start the description with volume energy. The volume of the nucleus is proportional to A. That is, as the atomic number increases, the volume of the nucleus increases. The basis for this term is the strong nuclear force of attraction among the protons and neutrons, which is taken as A into A to the power A minus 1 divided by 2. However, The strong force has a limited range, that is, the nucleons may interact strongly only with its neighbors and not with the far away nucleons. Therefore, the number of pairs that actually interact is roughly given by the above formula. Thus, volume energy is taken as proportional to atomic number, and that is equal to A1 into A. We will also have to discuss about surface energy, Coulomb energy and asymmetric energy. That would be done in our next class.